Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have this integral to look at. It's the integral of sine x minus cos 2x plus 1 all over cos x plus sine 2x dx. Now how would you approach this? What technique of integration would you employ? Looking at this expression here, direct use substitution will not work here, because if you differentiate the denominator it does not give you the numerator. If you let u be equal to the numerator, for example, differentiate, it doesn't give you 1 over this one here. So what would be the approach? Now, in trigonometry, the first approach is to see if you can simplify that integrand and see if it gets to a very simple expression that you can work with. In this case, that's exactly what we're going to do. So we'll start by simplifying, trying to reduce the integrand and see if we can get a simple trig expression that we can work with. So we have the integral of sine x minus cos 2x plus 1 sine x all over cos x, the integral of that, cos x plus sine 2x dx. So like I said, the approach is we're going to look at cos 2x and we're going to look at sine 2x. That should take us to what we call double angle formula. Let me remind you that cos 2x has three expressions. The first expression is cos squared of x minus sine squared of x. The second expression is 2 cos squared of x minus 1. The third one is 1 minus 2 sine squared of x. Now, which expression would you take here? Looking at the expressions surrounding this, we have a 1 here and we have sine x there. This sine x here allows us to actually select this one, because that's the expression that has sine squared, and with a 1 here we know that this one here will take care of that one out there. And therefore on this one here, sine 2x, there is only one expression for that. Sine 2x double angle formula, this is just 2 sine x cos x. Remember this. And therefore this integral changes to the integral of sine x minus, remember to use brackets here because of that minus sign. I'm going to select this one, 1 minus 2 sine squared of x plus 1, and I'm dividing this by cos x. Remember in the denominator we have cos x plus, and that expression there, sine 2x, must be replaced by this 2 sine x cos x, and then we have dx. Nice. Now let's remove these brackets here. We remove the brackets and simplify. So this is the same as the integral of sine x minus 1 plus, remember that minus sign will change the signs inside there, 2 sine squared x, and then we have to say plus 1. Remember what I told you, the minus 1 plus 1, this one is taken care of, those ones cancel. Down there we have cos x plus 2 sine x cos x dx. Now simplifying in the numerator, we reduce it to the integral of sine x plus 2 sine squared x all over, in the denominator we still have cos x plus 2 sine x cos x, and then we have dx. Fantastic. Now you can see that we are going to have to factorize now. The numerator, there's a common factor, and the denominator, there's also a common factor there, as you will see shortly. Taking us to the second page. Let me put these papers in order. Taking us to the second page. Now, here we go. So what we're saying now is this integral here is the same as the integral of the common factors you see in the numerator. is sine x, and open brackets there. Sine x into sine x obviously is 1 plus sine x into 2 sine squared x is 2 sine x. And we're dividing this by the common factor in the denominator is cosine of x. As you can see, cosine of x into cosine of x is 1 plus cosine of x into 2 sine x cos x is 2 sine x. And then we have dx. Now, as you can see, this expression cancels that one. So what do we have now? We have the integral of sine x over cos x dx. Fantastic. Now we can use substitution. So now I'm going to let u be equal to cos x, the denominator. Differentiate u with respect to x. Du dx will be equal to, remember, derivative of cosine is minus sine. This is what you have. Multiply by dx both sides. Du is going to be equal to minus sine x dx. Get rid of the minus sign on the right hand side. You say why? Because you can see sine x dx there. So we don't need the minus sign on the right hand side. So this means we have minus du is equal to sine x dx. Fantastic. Now this integral changes to, firstly, the integral of 1 over cos x times sine x dx. Exactly the same. This one is exactly this one. Now where I have this, I'm going to have that. And 1 over, this must be u because you can see it here. So therefore this integral is the same as the integral of 1 over u times minus du, because that is minus du, as you can see. Take the minus out just to complete this one off, taking us to page number 3, just to finish this one up now. So we're now saying that that integral is the same as minus the integral of 1 over u du. And this I've shown you a couple of times in the previous videos that this is just minus the natural log of u. And then we have to say plus c because our integral does not have limits of integration. It's an indefinite integral. Now if you do not want the minus, using laws of logs, this is the same as a log, the natural log of u to the power minus 1, like so. Remember which law of logs are we applying? I've given you this a couple of times. The natural log of t to the power alpha is equal to alpha times the natural log of t. Now, if I have minus natural log of u, where am I at? I'm here in that on that form. This, remember, is the same as minus 1 times the natural log of u, where your alpha now is minus 1. Where must it come? It must come on u, because here, remember, to move from here to there, the alpha becomes a power of t. So minus 1 must become a power of u, and that's why you get this from that one there. But we still have to say plus c. And what is this? This is the natural log of 1 over u plus c. Let's move back. What is u equal to? U equals cosine of x, as you can see. U equals cosine of x. So where I see u, I must put cosine of x. So this is the same as you can see, we move this one up. This is the same as the natural log of 1 over cosine of x plus c. And what is this? Well, this is what we call the secant of x. So this is natural log of sec of x, and then we have to say plus our constant of integration. We know that c is actually a real number. Right, this is where we stop. You would also have stopped here if you wanted, just put cosine here, because u equals cosine of x. It would still be fine, but we normally like to end here, because if you would recall, sine over cosine is just tangent, and the integral of tangent is the natural log of a secant, like this. We have to say plus c, obviously. All right, I'm going to stop here. Tell me what you think about this integral. Was it easy? I think looks very intimidating, but you know, when you have this, that would be the first thing you need to do, is to try and simplify that. If you cannot see direct u substitution, try and simplify it, and if it works, like in this case, you're okay. All right, I'll stop here and I'll see you in the next one.